Hi to all. Welcome back to Easy BTech. In my last session, we have discussed about the Rolle's theorem and applications. And now in this session, I am going to explain about the one more important mean value theorem, that is Legrange's mean value theorem. Before that, so please like, share and subscribe Easy BTech channel. So the next important theorem, that is Legrange's mean value theorem. Legrange's mean value theorem. So it may also be written as LMVT, Legrange's mean value theorem. The statement of Legrange's mean value theorem. Statement: if F maps A to B tends to R such that F is continuous on closed intervals of A comma B, and F is derivable on open intervals of A comma B, then there exists at least one element, that element is C, which belongs to the open intervals of A comma B, such that f dash of C is equal to f of B minus f of A by B minus A. It is a statement of Legrange's mean value theorem. So F is continuous, students. F is derivable, continuous on open intervals, derivable on closed intervals. Then there exists at least one element where that element belongs to the given open intervals A comma B, such that f dash of C is equal to f of B minus f of A by B minus A is the statement of the Legrange's mean value theorem. So related to problem about this same theorem, verify Legrange's mean value theorem for f of x is equal to x cubed minus x square and minus 5x plus 3 on the interval 0, 4. Yeah, the solution. So Legrange's mean value theorem, the first condition is verifying it is continuous or not. Minus 5x plus 3 on the given intervals 0, 4. So what is the first condition, students? First condition is verifying f of x is continuous or not. So obviously it is continuous because it is a polynomial. F of x is a continuous on closed intervals of 0, 4. A second one, verifying the derivability, students. Derivability means doing the differentiation. X cube differentiation 3x square, x square differentiation 2x, and 5x differentiation is 5. That means f of x is derivable on open intervals of A comma B. So continuous derivable, then there exists at least one element C belongs to 0, 4 such that, so what is the condition? F dash of C is equal to f of B minus f of A by B minus A. So here the value of A is equal to 0 and the value of B is 4 here. According to the given intervals, the first element is A and second element is B here. Then finding the values of f of A and f of B, students. F of A, so that means f of 0. In the given question, if you are substituting in the place of x as a 0, then you will get the value of f of 0 as a 3. And f of 4, that means f of B, then substituting the value 4 cubed minus 4 square minus 5 into 4 and plus 3. So then you will get the value as a 31 for this answer. And the next, finding the value of f dash of C. F dash of C is equal to f of B. F of B is 31 minus f of A, that is 3, and divided by 4, that means 28 by 4, that is equal to 7. So what is the value of 7 here, students? The value of 7 is f dash of c. So according to the second condition, here in second condition, we know the value of f dash of x. That value is 3x square minus 2x minus 5. Then we need the value of f dash of c. F dash of c here. F dash of c here. Then simply substituting in the place of x as a c in the second condition, you will get the value of f dash of c. That is 3c square minus 2c and minus 5 is equal to 7. Using the second condition only, we are finding the value of f dash of c here. Now doing the simplification of this one, that means 3c square minus 2c minus 12 is equal to 0. Then finding the factors, of course the factors are not possible here. Then applying the formula, if it is a quadratic equation, ax square plus bx plus c is equal to 0. If factors are not possible, then finding the roots, formula is minus b plus or minus b square minus 4ac by 2a. And comparing the question, the value of a is equal to 3 and the value of b is minus 2 and the value of c is minus 12. The substituting the values to find the roots of this equation, then c is equal to minus b is the formula, students. Already b is having minus here. Then 2 plus or minus root of b square minus 4ac within the roots and divided by 2a. That means 2 into a. Then answer 2 plus or minus root of, that means 4 and plus 144 and divided by 6. This answer. And finding the final answer, that means 144 and plus 4, that means c is equal to 2 plus or minus root of 148 by 6. So if plus or minus c is there, students, here, then for c, 2 plus root 148 by 6 is one value and c is equal to 2 minus root 148 by 6 is the another value, because in the root plus or minus is there. By taking plus one value and by taking minus another value, then here c is equal to 2.6 is the one root and c is equal to minus 1.96 is the another value. So and here the value c is equal to 2.6 belongs to the given interval, open intervals 0, 4, because our statement states that here at least one element belongs to the intervals. So hence the Legrange's mean value theorem, LMVT, is verified. Legrange's mean value theorem is verified. Yeah, coming to the one more problem. Yeah, using LMVT, show that the question h less than sin inverse h less than h by root of 1 minus h square. So for 0 less than h less than 1. So here observe here, students, the question is not for verifying Legrange's mean value theorem. The previous question is for that related, verifying Legrange's mean value theorem. But in this question, verifying was not asked here. Using Legrange's mean value theorem only, we have to prove this statement. That statement is h less than sin inverse h less than h by root of 1 minus x square. For that purpose, first choosing the value of f of x here. So f of x is sin inverse x. Within the intervals, it was given in the question that intervals of 0, h. So what is the first condition in Legrange's mean value theorem? Proving that it is continuous. Of course it is continuous because it is inverse trigonometric. F of x is continuous on closed intervals of 0, h. And the second condition is derivability. That means doing the differentiation. F dash of x is equal to sine inverse x differentiation is 1 by root of 1 minus x square on the interval, open interval a comma b. So if satisfying these two conditions, then there exists at least one element C belongs to 0 comma h such that what is the main condition, students? F dash of C condition in LMVT. Condition is f of b minus f of a by b minus a. So here the value of a is 0 and the value of b is h. At first finding the value of f of a, that means f of 0, that means sine inverse 0 is equal to 0. F of b, that means f of h, that is equal to sine inverse h. Then again finding the value of f dash of c here. So how to find out f dash of c here? Simply, students, observe the second condition. In second condition, you know the value of f dash of x. What is the f dash of x value? 1 by root of 1 minus x square. We need the value of f dash of c. Then simply substituting in the place of x as a c here. Then you will get the value of f dash of c as 1 by root of 1 minus c square. So we are having f of a value and f of b value and f dash of c value also. Now it was given that here f dash of c is equal to f of b minus f of a by b minus a is the LMVT condition. So what is the value of f dash of c here? 1 by root of 1 minus c square. And f of b is sine inverse h. F of a is 0. b minus a is h minus 0. Finally the answer is sine inverse h by h. Remember this answer, students. So what is this answer here? So 1 minus root of 1 minus c square value is sine inverse h by h. Coming to the proof of the given question. So suppose if we know that c belongs to a comma b, according to this condition, we may write down this condition as a less than c less than b. Okay. So in this Legrange's theorem also, we are having the condition c belongs to 0 comma h. Then using the condition, we are writing this condition as 0 less than c less than h. So what we have to do here, students? Here the value of 1 by root of 1 minus c square is there now. The changing the middle term, this c term, as in this term to substitute this value, sine inverse h by h value. For that purpose, we are using some elementary transformations here. Observe here. First, see I am writing here, that is 1 by root of 1 minus c square is equal to sine inverse h by h. Okay. So first we need c square value. C square. So using the transformation, that means squaring 0 less than c square less than h square. And again what we need here? Minus here. Then again using the minus also. If you are applying minus, less than becomes as a greater than. Then minus c square greater than minus h square. And again what we need here? From 1 subtraction. So 1 minus 0 greater than 1 minus c square greater than 1 minus h square. Again what we need though here? That means a root here. Then root 1 greater than root 1 minus c square greater than root 1 minus h square. And again what we need here? After getting root of 1 minus c square value, we need 1 by of that value. Then 1 by root 1. If you are taking 1, then greater than becomes as a less than. 1 by root of 1 minus c square less than 1 by root of 1 minus h square. So now only I told you now, please remember one value. So what is that value here? 1 minus 1 by root of 1 minus c square is equal to sine inverse h by h. This value, this total value here. Substitute this value in middle. This proof. 1 by root 1 is 1 less than 1 by root of 1 minus c square is sine inverse h by h and less than 1 by root of 1 minus h square. So now the statement, the given question consisting as here h less than sin inverse h was given here, then multiplying with h here, h less than sin inverse h less than h by root of 1 minus h square. That's the proof of this statement. This is one of the important problem for you students. And the one more important problem in LMVT, using LMVT, prove that, one of the very important question, using LMVT, prove that if A less than B, then B minus A by 1 plus B square less than tan inverse B minus tan inverse A less than B minus A by 1 plus A square. This is the one proof. And also prove that first one, pi by 4 plus 3 by 25 less than tan inverse 4 by 3 and less than pi by 4 plus 1 by 6. So it is a very important question for you. So now the proof of this problem. Here also verify theorem was not asked here, students. Verify was not asked here. Using Legrange's theorem only we have to prove this one. First of all, proving this statement, and using this statement we are proving the first question of this one. Yeah, okay. So B minus A by 1 plus B square less than tan inverse B minus tan inverse A less than B minus A by 1 plus B square. So choosing the value of f of x here is equal to tan inverse x. So the intervals A comma B only. The first condition is verifying it is continuous or not. So we know that it is tan inverse x is continuous on A comma B. And second one, derivability, then f dash of x is equal to 1 by 1 plus x square on A comma B, satisfying the two conditions. So if the two conditions are satisfied, then there exists at least one element, C belongs to A comma B such that f dash of C is equal to f of B minus f of A by B minus A. This is the Legrange's theorem statement. F of B minus f of A by B minus A. You are finding all values here, students. So here A is A only, then f of A is equal to tan inverse A. B is B only, then f of B is equal to tan inverse B. B minus A only, then f dash of C using the second condition 1 by 1 plus C square. Then substituting in the condition, f dash of C is 1 by 1 plus C square is equal to f of B. F of B is tan inverse B minus f of A is tan inverse A divided by B minus A. You please remember this value, tan inverse B minus tan inverse A by B minus A. So we need this value when we are proving the statement of this problem. So in this problem again it was given that C belongs to A comma B. So we know that A less than B less than C. So see here, students, we need C square. At first we need C square here. Then doing the square here, A square less than C square less than B square. And again we need 1 plus here. Then 1 plus A square less than 1 plus C square less than 1 plus B square. And again we need 1 by here. Then again doing the 1 by 1 plus A square. If we are applying 1 by here, less than symbol becomes as a greater than symbol here. Then greater than 1 by 1 plus c square greater than 1 by 1 plus b square. So now we are having this value. What is that value, students? 1 by 1 plus c square value we are having here. The substituting this total value in the middle of this statement. Then 1 by 1 plus a square greater than. So what is that value? Tan inverse b minus tan inverse a by b minus a greater than 1 by 1 plus b square only. So coming to the middle term here, the middle term denominator is consisting b minus a here, then doing multiplication with b minus a here, then b minus a by 1 plus a square greater than tan inverse b minus tan inverse a greater than b minus a by 1 plus b square. Now please observe the question there. The question, the first term b minus a by 1 plus b square is there in the question. This is the first term and this is the last term in the question. Then interchanging the values, then symbols also will be changes here. B minus a by 1 plus b square greater than becomes as a less than. Then tan inverse b minus tan inverse a less than b minus a by 1 plus a square. So hence proved. Using LMVT we proved this one. So using this proof we are having one deduction here in this question. We are having one deduction. So the deduction, for the deduction we are using some substitutions here only. So deduction. So for this deduction we are taking the substitutions as a is equal to 1 and b is equal to 4 by 3 in this proof. This proof only we are substituting. So first one here b minus a is there. That means 4 minus 3 minus 1 by 1 plus b square means 16 by 9 less than tan inverse b means 4 by 3 and a means tan inverse 1. And b minus a 4 minus 3 minus 1 by 1 plus 1 square. A is 1 here. Then 4 minus 3 minus 1, that means 1 by 3 by taking the LCM as a 9. So 9 plus 16, that is 25 by 9. 25 by 9 less than tan inverse 4 by 3. So tan inverse 1 answer is pi by 4. In 45 only tan value 1 here. Then 1 by 3 by 1 plus 1 square. Then 1 plus 1 is nothing but 1 only here. Now 1 by 3 and doing the reciprocal into 9 by 25 less than tan inverse 4 by 3 minus pi by 4 less than 1 by 2 into 1 by 6. This value is also reciprocal value because denominator 2 is there. Then the reciprocal value becomes as a 1 by 2 there. Then doing the cancellations 3 1 and 3 3. That means 3 by 25 less than tan inverse 4 by 3 minus pi by 4 and less than, and this value 1 by 3, 1 by 3 and 1 by 3 here. That means 1 by 6 here. Then adding pi by 4 on both sides. Then 3 by 25 plus pi by 4 less than tan inverse 4 by 3 less than 1 by 6 plus pi by 4. So hence proved using the Legrange's mean value theorem. We did the proof and deduction also. Okay, in this session about Legrange's mean value theorem statement and 2 applications completed. In the next session also the same topic, Legrange's mean value theorem only. Okay, thank you.